Okay, hello everyone. This is Cha-Cha. Today I want to be talking about Hess's law. So Hess's law is something that is related to enthalpy. So like if you have enthalpy or delta H, essentially it's saying that the whole of like sorry, the whole is the sum of all of its parts. So if you have a chemical reaction, then when you sum up all of those individual parts to get to your final equation, then that's your total enthalpy for that said reaction. Um, yeah, sometimes they be products minus reactants, but a lot of times it's just a sum um of it. Well, delta H can be this is like not sum. This should be delta H is products of minus reactants. Just delta, just always remember that delta is always products minus reactants. So before we go into like problem. First, here are some things that you should always do. You should always balance the equation. So a lot of the times, on the MCAT, they'll have something and they're going to try and trick you where you don't realize that the equation is balanced. Like, let's say you have like, for example, like this carbon on the reactant side has two. This is C4. So you need to multiply this side by two in order to that number of moles by two in order to have equivalent carbon number, and then you multiply that subequation's enthalpy by like that integer too. So I'll explain that in a minute when we actually get to a practice problem, just because it's kind of hard to do without um like the math. And then like if you're gonna switch aside the reactions, like if you're going from like reactants to products, but you actually like when you see the final reactants, you say, hey, like this R that's on the product side, it needs to be over on the reactants. So um you have to switch it. So when you switch it, you'll switch the sign of the enthalpy. So like let's say that this one, let's call this equation one, is a positive enthalpy. So if this is positive, but you need to have the react R on the reactant side, then this will now be a negative enthalpy, if that makes sense for equation two. Some more things about enthalpy. It's a state function, so you don't care about the journey, only the beginning and the end. So you could have had the hardest path ever to get to the endpoint from the beginning, but it doesn't really make a difference. Like let's say for example, like you had a cliff, right, that you had to go over versus like a straight line going through the valley. It doesn't make a difference because the ends and the beginnings are the same point for enthalpy. Whereas work, this would make a lot of difference. If you had the cliff versus straight, since you do care about the journey, since that's a path function. Um, so I took this equation from ChatGPT just because like ChatGPT is like actually like really good generating problems, especially if you go from different difficulty levels. So since it's like a moderate sort of difficult one, it's a great to generate your problems. So let's just kind of look at what it's doing. So you have carbon, solid, oxygen. So that delta, that enthalpy is negative 393. This one, equation two, negative 285. Equation three, negative 566. So as you can see, this is our final one. So this is the equation that we care about. So what you want to do right off the bat is see where is everything in the equation. So you see carbon, carbon is on the reactants. So, and like none of the other ones are in the final equation, like the oxygens and CO2. That's not in the final equation. So you know that this is gonna have to cancel out eventually. And then let's see. So you see water in the final. So water over here is on the product side, which means that we're eventually going to have to reverse this. So this will have to go the opposite way. And you could tell that you're probably not going to do anything to that equation too, just because water only has 1 mole of it. So you're not going to multiply it by any integer. Whereas for this one, you have CO um and H2 is also on the side, which makes sense that you'd want to switch it. So it like tells you for sure that you're going to reverse the equation. Um, and then for this one, you have CO and CO here. But for this one, you can see this has a 2 for the mole or for the coefficient, and this one has nothing. So that means that you're going to want to multiply this by 1/2, and also because the CO is on the reactant side, but it needs to be on the product side. So you're going to want to flip the equation. So what do I mean by this? Okay, so for this one, that was equation 1. You're not doing anything. So you're keeping this delta H will stay the same. So that's equation 1. For this one, for equation 2, you have H2O and then H2 plus 1/2 and O2. So basically all I did for this one, just to have H2O and H2 on the same side, or on the respective sides that you need for the final equation, H2O is here. So negative 285, right? That was what it was initially. So this is going to be positive 285 kilojoules, 0.8 kilojoules. It's because you flipped the equation. And then for this one, for equation 3, right? So there's like 2 steps that you have to do. So always make sure that the equation is balanced. So the first thing that you want to do is multiply this by 1/2. So you would multiply 566 times 1/2, and math isn't my strong suit. So let me just pull up a calculator just to make sure everything's okay. It's 283 kilojoules. So that's negative 283. And then notice how I flip. You need to flip this too. So let's CO2. This is got flipped. The CO2 is now on the reactant side, where here this was on the product side. So this was originally negative 566. So now it's 283. And then your total delta H for that equation, you add everything up. So 283 plus 285.8 and then minus 393.5. So it's 175.3 kilojoules. And remember, this is positive. So this means that this is endothermic. So it means that you need energy to break bonds. Or like you need energy to go into the system in order to do what you want to do. Um, yeah, and that's pretty much all I have on Hess's Law. Hopefully that was helpful. But and once again, my name is Shasha. Have a good rest of your day.